Welcome to Homework Lib.
This problem involves testing whether the observed distribution of candy colors matches the expected distribution based on the given probabilities, and we can perform a chi-squared goodness of fit test to compare the observed and expected frequencies of each color. So the null hypothesis would be that the observed distribution of candy colors matches the expected distribution. In other words, the machine fills the bags with candies according to the stated probabilities. The alternative hypothesis is that the observed distribution of candy colors does not match the expected distribution. I'm abbreviating here. Then we would set our level of significance, 0.05 is typical, and we'd calculate the expected frequencies. These are based on the total number of candies, which is 224, and the given probability. So the expected number of brown candies would be 224 times the probability of brown, which is 0.25, and so that'd be 56. The expected orange would be 224 times the probability of orange, 0.31, so that's 69.44. For green, that would be 224 times 0.28, or 62.72. And yellow would be 224 times 0.16, or 35.84. And the chi-squared statistic is calculated as the sum of the observed, the difference between the observed and expected frequencies squared divided by the expected frequency. So for brown, that would be 42 minus 56 squared over 56, which is 3.5. Well, I'll come back and do that. For orange, it would be 64 minus 69.44 squared over 69.44, plus 53 minus 62.72 squared over 62.72, plus 65 minus 35.84 squared over 35.84. And let me get that in a calculator. About 29.16, and then the degrees of freedom is going to be the number of categories minus 1, so that's going to be 4 categories, 4 colors minus 1 is 3, and we look up the in the chi-square distribution table with 3 degrees of freedom and an alpha of 0.05, the critical value is 7.815. Our test statistic of 29.16 is much larger than this, so we would reject the null hypothesis. There is enough evidence to conclude that the observed distribution of candy colors does not match the expected distribution.